Not only do computers read code, you also read code. A lot. Most of the time, actually. In fact, Uncle Bob says that the ratio of time spent reading versus writing is well over 10 to 1. We are constantly reading old code as part of the effort to write new code. But a lot of the time, you look like that. You can't understand what I try to do. Programming is hard, inherently, just as the way it is. But I make it harder by writing code that's hard for you to read. Luckily, this is treatable. Hi, and welcome to my clinic. My name is Moran. I'm the CEO and founder of Women on Stage. Women on Stage is a global community platform to showcase, book, and train women professional tech speakers for any event, conference, meetup, or webinar. In my previous background, I have 10 years of experience working as a software developer, and other than that, I'm also a social psychologist. Obviously, I don't practice it for a living, but I do have a master's degree in social psychology. And I'm here today to talk about how each and every one of you can use cognitive psychology in order to better understand how we read and interpret code. And as a result, take away a few scientifically backed techniques on how to write code that is more readable. So, what makes code readable? Readability is all about conveying intent and making that intent clear to others and to your future self. Have you ever looked at a piece of code and thought to yourself, what the hell? Only to discover a few moments later when you annotate that you were the one who wrote it a few years back? Me too. So let us start our journey by speaking about how to make your intent clear to others and to your future self. So let's play a little game. I'm going to show you a list of words on screen, and what I want you to do is to shout out, to see the words, and to shout out their colors and not the word itself. Okay? The color of the word and not the word itself. Don't worry, let's do a little test together. Remember, say the color of the word and not the word itself. All of us together. Green, blue, green, yellow, blue, blue, red, yellow, red, green. Did you get it? Did you get the hang of it? Okay, are you ready for the real thing? Okay. Okay. Green, blue, red, green, yellow, blue, green, green, red, blue, red, yellow, blue, blue. Did you feel it? Did you feel the pain? This game is called the Stroop task. The Stroop task became a tool for American intelligence officials during the Cold War. A covert agent could claim not to speak Russian, but it takes longer to recognize the Russian words for color. This is because we excel at reading and processing text. We're so good at it that we cannot turn this feature off. When we see text, we read it, and we infer meaning. That meaning creates expectations. When the colors doesn't match that expectations, it hurts. The names we give our functions and variables create expectations as well. When the values doesn't match those expectations, it can hurt just as much. So that's why good names are all about creating expectations and fulfilling them. What do you expect the variable is readable to be? I'd expect it to be a Boolean and not the string false. And what about collection size? I'd expect it to be a number and nothing else. But of course, none of you would write code like that. Of course not. But maybe you've seen something like this. What do you expect file names to be? A list of file names, obviously. But wait, Do they include the relative paths? When I debug it and I see what the variable is holding, it kind of makes sense to me. The name, it kind of makes sense to me. But if instead of asking yourself, does the name make sense or not, ask yourself, what will the next reader, what will the next developer expect to see, it's easier for me to understand that I probably need a different name. Good name is unambiguous and probably creates expectations into our reader's mind. So when I was working at Wix a few years ago, I found a weird bug in one of our blog components, and it got me to look at the isReady method. So what do you expect isReady to return? Obviously, you expect it to return a Boolean, which it did, but the thing that really surprised me is that the bug was introduced because of an HTTP post message that was being sent out from inside the isReady method. And it really surprised me. So, and I want to be clear here that this is good code. This code served millions of users on a daily basis. So the first thing I did, other than fix the bug after I found it, is to make sure that no other developer will experience the same surprise as I did. And to be clear, to create the proper expectations for the next reader. So I renamed the function to isReady with side effects. And I want to be clear that this happens everywhere, even in popular front-end frameworks like AngularJS. Let me quote this question from Stack Overflow. What are the differences between a service, a provider, and a factory in AngularJS? It has more than 3,000 app votes and almost 2,000 stars. It has been viewed almost 800,000 times over the last 9 years. Think about those numbers. Think about how many developers were struggling with the same question because the naming, because it failed to create the proper expectations. To sum this section up, I would say, don't think about, when you're naming a variable or a function, don't think about does it make sense or not retroactively. Ask yourself, what will the next developer expect to read, and fulfill those expectations. Okay, so let us play another game. Some of you might remember the famous Simon game from the 80s. And for those of you who don't worry, it's pretty simple. You're going to see, what I'm going to show you is a list of colors on screen. So what you need to do is to see the colors, remember them, and after that, shout them out loud. Don't worry, you'll get the point. So let's do a little trial first. First me and then you. Red, green, yellow, blue. Okay. Let's try the next one. Red, green, yellow, blue, green, blue, 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 red, yellow, red. Very nice. So, what I wanted to show you with this game is that our memory capacity is limited. There's only so many colors we can remember. This has been called in psychology our working memory or our short-term memory. You can think of it as our RAM. So our RAM capacity is limited. In fact, research has shown that most people can store in their working memory an average number of between 5 to 9 items on any given time. This has been introduced as the magical number 7 plus minus 2. But what if we want to remember more? How can we hack the limits of our memory? Luckily, we can do so by using chunking. Chunking basically means taking long pieces of information and dividing them up into smaller, meaningful parts or units. So let's see a little example of that. Okay, imagine you had this long list of colors from the Simon game before. Take a few seconds and try to memorize the entire list. Please raise your hand if you can recall the entire list without making any mistakes. Amazing. Okay, so let's try it with chunking. Rugby, burger, rugby, burger, rugby burger, rugby burger. Now raise your hand if you can recall the entire list. Great. So, and let's see another example of chunking. Say I would ask you to remember this entire array of 16 characters. It's really hard at first glance. But by using chunking and dividing them up into smaller, meaningful words, now it's so much easier to do so. And I want to emphasize that for a computer, in both cases, the storage, it probably needs the same amount of storage. But for human beings, the second example is so much easier. And I bet you probably think to yourself, well, okay, so all of your examples are well engineered, and what does it have to do with code in real life examples? So I'm glad you asked. And let's see a little example of chunking with code. Say you had a function that does a hotel reservation, and it gets all of these parameters. So at first glance, when I read it, it's really hard to keep track. It feels like, okay, stacks overflow my mind, and by the time I get to the end of the function, I can't remember where I started. And obviously, all of these parameters are mandatory. I can't do the function without them. But if I use chunking and I divide them into smaller, meaningful objects or namespaces, now it's so much easier to read the signature of the function. And let's see another example. Say you the make reservation function from before would look like that. Please don't read it. It's long on purpose. But once again, when I read it, it's really hard to keep track. And when I say it's hard to remember, I don't mean that I need to remember it in a month from now. I mean that while I read it, as I read it, it's hard to remember. By the time I get to the end of the function, I can't even remember where I started. So if I use chunking and I divide them into smaller, meaningful functions, now it's so much easier to understand the bigger picture and to understand the story this function is telling me. And it's also so much easier to debug, because if I know there's a bug in one specific line, I only need to step into that specific line. I don't need to debug the whole thing. And let's see one last example of chunking. Say you had this function on a first glance. I bet if I give you some more time, you probably figure out what it does. But once again, on first glance, it's really hard to understand. This one-liner looks like minified code. But if I use chunking into smaller, meaningful steps, and I name the variables accordingly, now it's so much easier to understand what is written here. And I can see that the function is taking the first red, last green, first blue, last yellow, and then concatenate them all. So I understand that this function is chunking by colors. To sum this section up, try to think about which parts of your code can be easily chunked together into smaller, meaningful objects, namespaces, arguments, functions, and separate steps. Okay. I want to ask you something. How many of you are currently aware of the sensation of clothes on your body? How many of you are currently aware of the sensation of the pressure of the chair against your back? How many of you are currently aware of the sound the air conditioning is making? These all somehow magically disappear until we're being reminded of them. That's our amazing filtering mechanism. That's our mind's amazing filtering mechanism in action. All day long, our senses are constantly being bombarded by sound, light, temperature, smells. That's why our minds are masterpieces in processing and filtering out data. The thing is that if your mind can predict the noise, it can easily filter it out. Daniel Kahneman, a Nobel Prize winner for the realm of human decision-making, describes two modes of thinking. System 1 is fast, it's instinctive, it's the more emotional part of the brain. And system 2 is slower, it's more deliberate, it's the more logical part of the brain. System 1 is the one that does the filtering out. Have you ever driven your car to work only to discover when you get there that you can't remember the drive? This is where it has a cute name. This is called the highway hypnosis. It's when System 1 had automated the mundane task of driving, so System 2 can focus on what's really important, which is the podcast you're listening to, or the project you have at work, or what you're going to have for dinner. When System 1 doesn't know what to do, it interrupts System 2 immediately. When we keep noticing inconsistent coding styles, line breaks, single versus double quotes, missing semicolons, it's like System 1 is saying, hey, I don't know what to do here. Let's play it safe. Let's ask System 2. Having your code style consistent is just like driving a long, straight road. It doesn't grab your attention, and you can focus on what's really important, which is the business logic itself. But I bet you probably think, well, yeah, we have linters for that, and we have automatic formatters to do all of that. We don't need to worry about it. But it's more than that, and there is stuff that linters just can't solve, like naming. For instance, if you have similar actions and you use different names for the same action or similar actions, it's so much easier versus using the same word for similar actions. It's so much easier for System 1 to do the filtering out, and you can focus on what's really important, which is the differences between the functions. System 1 is a superpower. It can instantly locate the source of sound when someone calls your name. It can complete well-known phrases like, "My name is Inogia Montoya. You killed my father?" It can read a text out of the billboard. It can drive a car on a long, empty road, and so much more, just as long as you are predictable. So I say, let System 1 do its job. Write predictable code and make filtering easy again. But sometimes those interrupts can be useful. For instance, when there's a child who runs into the road, you want to be able to stop your car immediately. And we can use that in order to put warning signs into our code. For instance, we can say, hey, don't use me, I'm deprecated. Or we can say, I know functions should do only one thing and to do it well. I do two things. Pay attention. Or you can use the is ready with side effects that I showed you before. So to sum this section up, I would say, write predictable code and make filtering easy again. So we've discussed how to properly create expectations and fulfilling them into our readers' minds. We talked about how we can easily chunk our code together into smaller, meaningful parts, and we talked about writing predictable code. But there's one inherent problem with all of these, and that is all subjective. So the problem is that the only way to actually verify that your intent is clear, that your code was readable, is by doing a code review. And if there's one thing I want you to take away from my talk today, and one thing alone, is that you need a code review. Doesn't matter how skilled you are, doesn't matter how many years of experience you are, everybody needs a code review. And if you don't believe me, I hope I'll show you it soon. So let's play another game. I want you to raise your hand when you spot the man's face, okay? Do you want me to tell you? Okay. So if you didn't see it, it's right there. But now that you've seen it, you can't unsee it. It just pops out. You can't understand how you couldn't see it in the first place. It's the same thing with your code. Since you are the one who wrote it, it's clear to you. You already know your intent. You were the one who wrote it. But the problem is that others only see a bunch of coffee beans. Let us play, so the only way to verify your intent is clear is with a code review. Another game. Okay, and this time it's a competition. Let's test how good you are. You'd be surprised to see how many fail at this. And if you already know this game, please don't ruin it for others, okay? So I'm going to show you a video, and I want you to count how many times the players wearing white, and only the players wearing white, pass the basketball. Okay.
This is a test of selective attention. Count how many times the players wearing white pass the basketball. How many passes did you count? The correct answer is 15 passes. But did you see the gorilla? This video is from research by Daniel Simons and Christopher Chabris and is copyrighted. It is available for use in talk.
Okay.
This is...
When you tell me where to focus, that is all I see. When you ask me for a code review and then explain to me your code, it's like you're telling me to count passes. I won't be able to see the gorillas in your code. I won't be able to see the bugs in your code. I won't be able to see the design flaws. And worst of all, you won't know if your code is readable or not. That's why code reviews should always be cold code reviews. And by cold, I mean, don't give me an intro, don't tell me what you did or explain your design. Just send out a pull request and the reviewer will look on their own. Code review is a dish best served cold. Okay, so let's see what you learned. This is the last game, I promise. Once again, it's a competition. I'm going to show you a video, and what I want you to do is to count how many times the players wearing white pass the basketball.
The monkey business illusion. Count how many times the players wearing white pass the ball. The correct answer is 16 passes. Did you spot the gorilla? For people who haven't seen or heard about a video like this before, about half missed the gorilla. If you knew about the gorilla, you probably saw it. But did you notice the curtain changing color or the player on the black team leaving the game? Let's rewind and watch it again. Here comes the gorilla, and there goes a player, and the curtain is changing from red to gold. When you're looking for a gorilla, you often miss other unexpected events. And that's the monkey business illusion. Learn more about this illusion and the original gorilla experiment at theinvisiblegorilla.com.
Did you see the gorilla? Did you see the curtain changing its color? Did you see the player on the black team leaving the team? You need a code review. On a more personal note, I would like to share with you the fact that I used to hide the fact that I also studied psychology other than computer science. It was because in one of the first interviews I had when I just finished school, an interviewer laughed at me about it and claimed I was wasting his time because of it. I always thought developers should be like this cold ninja robot fella, and if I'm the kind of person who understands how people think, act, analyze, and behave, perhaps I should just keep it to myself. But now I know that knowing these patterns and using them in predicting actually makes me a better coder, a better reviewer, and a much better engineer. And that's because any fool can write code that a computer can understand. Good programmers write code that humans can understand. Thank you.